Hello Pre-Calc stars. Today we have lesson 89, the ellipse part 2. Yay! So we remember the standard form of our ellipse is x squared over a squared plus y squared over b squared equals 1. And our trusty graph, alright, hope maybe yours looks better than mine. This is negative a 0, this is a 0, we have 0 b, and we have 0 negative b. Okay, and that means this distance here is b, and this distance here is a. Okay, now this is also true if our ellipse is elongated on the y-axis. Okay. That is totally fine. Now, if I was to just draw an ellipse, we talked about this a little bit last time. We have our two foci, F1 and F2, and they have these two distances here. The sum of the distances is a constant. We're going to call it 2a. So distance 1 and distance 2. Okay? Now, on my graph, here's my ellipse. They're slowly getting better. Okay, here's my foci 1, here's my foci 2. And I have this distance here and here. This distance is A, which is the same A that I'm talking about up here. This distance is A. This distance of this right triangle I have here is B. And look at us, we have C. I have a right triangle, which I can use Pythagorean theorems, c squared plus b squared is a squared, to solve right here, my foci. This is how we're going to write the equation of an ellipse. So, let's jump into an example. Write the equation of an ellipse with vertices at plus or minus 5, 0, and foci at plus or minus 4, 0. You always have to draw a diagram. Always, 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 always. So, this is negative 5, this is 5, right? And I have my ellipse goes through those. Okay, this point I don't know yet. That's what we're looking for, nor this point. I do know, however, my foci is at plus or minus 4, which means this distance right here is 4. Now, if I draw this triangle here, I'm looking for B, right? I know my A, I'm looking for B, and I know that this distance here on the hypotenuse is the same distance as A here. How cool. So then I can solve for B and say B squared plus 4 squared is 5 squared. So B squared is 25 minus 16. So B squared is 9. B is plus or minus 3. So, my equation, I have x squared over, I have 5 squared, which is 25, plus y squared over something equals 1. My something is what I just solved for, b. 3 squared, which is 9. Don't forget to square it. You have to draw this picture. It's part of what I'm grading. Okay, but this is the equation that we're looking for. So let's do another example. Example 2, write the standard form of the ellipse with vertices at 0 plus or minus 6 and foci at 0 plus or minus 5. So this is telling me, right, this is why it's important that your graphs are accurate. This is 6, this is negative 6, this is my foci 1, foci 2. My graph is longer on the y-axis. And I will have x squared over something plus y squared over 36 equals 1, right? My vertices here, I have 0 plus or minus 6. Now, always draw your diagram. The distance to my foci is 5. I'm looking for this distance here, and I know that this distance is the same as my A. So in this triangle, I have 5 squared plus b squared is 6 squared. So b squared is 36 minus 25. So b squared is 11. So b is plus or minus the square root of 11. So this value I square and put here. The square root of 11 squared is 11. Okay. Let's do another example, a little bit harder. A horizontal ellipse, nice they tell us that, has a major axis length of 10, minor axis length of 4, and center at the origin. Find foci, graph the ellipse, and write equation. Okay, so as always, we begin with a diagram. We know it's a horizontal ellipse, so I'm just going to go ahead and draw it. Now, my major, if we remember, my major axis is this whole thing here, which has a length of 10, which means this length here is 5. My whole, from here to here, minor premise has a length of 4, which means this length here is 2. So I'll have x squared over something plus y squared over something equals 1. I know this point is negative 5, 0. This is going to be 5, 0. 0, 2, 0, negative 2, which means I'll have x squared over 5 squared, which is 25, and y squared over 2 squared, which is 4. Here's my equation. Now I'm looking for a foci. Okay, I know that this distance is 5, and this distance is 2. Let's call this C. So 2 squared plus c squared is 5 squared. So c squared is 25 minus 4, which is 21. So c squared is 21, so c is plus or minus the square root of 21. So my foci are the square root of 21, 0, and negative square root of 21, 0. The whole thing, and my diagram was my graph. How convenient. Okay, when you write your foci, you have to write it as an ordered pair. You cannot just write plus or minus square root of 21. You have to write it as an ordered pair. All right, I'm going to now grant you the gift of working on your other homework. That is all for now.